Sorry, I don't know if you can hear me. I do apologize for the breaking transmission. So two things. I was on a call with someone important, I suppose. Anyway, and yes, it's work related. And then I had a bit of a technical issue here, but I don't know if you can hear me or if you can see my screen. I've just shared my screen. Hello, can you hear me?
Yes, sir, I can hear you.
Okay. In that case, we continue. I do apologize that we couldn't make. I could not make it yesterday. I'm keeping track of sessions that we've missed, so we'll continue with these weekend classes until we catch up, or at least until we are content with the fact that we are almost done with the content we're supposed to cover in this course. And it turns out that there's still quite a few things we're supposed to cover, like configuration management. We have to look at testing, and then finally we'll have to look at the theme we tagged as experimental software engineering, right? And so my thinking was actually that the next part of the design we're supposed to look at, I'll probably skip that, because for the purposes of what we're doing in the projects we're working on, what we've covered so far should be sufficient. I'll think things through, and if I feel like we need to gloss over the next part of the design we're supposed to look at, then maybe we can take advantage of tomorrow and day after tomorrow or something. But I'm wanting for us to really quickly look at configuration management, because at this stage you should be in a position to start implementing or writing code, right? And once you start writing code, it turns out that ideas that we're going to discuss under configuration management are extremely important, especially that you're working in groups and you're not co-located, right? So we need to go through that lecture series. But anyways, we continue our conversation from where we left off. I do believe we got to a stage where we started looking at structural model, a specific type of structural model. And specifically, we said we were going to focus our attention on class diagrams, which we started looking at, right? The reason is simple. We are assuming that everybody is going to take an object-oriented programming approach as they're writing software. Oh, I forgot, there's also an agile theme that we're supposed to look at. But at this stage, we're just following through with the traditional software development model, and we're saying that everybody is going to take an object-oriented programming approach, right? This is the assumption we're making here, which is why we're discussing class diagrams, right? Granted, it was more or less, so it's more or less like revision. It's something we looked at, also we discovered, that's what you taught us, this is what we looked at in 2010. But, okay, so there we go. We started our discussion of class diagrams, and then we ended up to a stage where we were discussing attributes, right? So the syntax for how we get to represent these attributes as we are coming up with class diagrams. Very simple. We discovered that there are certain key components associated with a UML class diagram. This is UML version 2.0, by the way, or 2.x if you want. Visibility, the variable, the type, and the default value. The visibility will tell you how accessible, or what entities are able to access that particular attribute. You remember we're still discussing attributes here, right? So we did a bit of revision, and we discovered that what we're actually making reference to here is public, private, protected, and the default attribute, or otherwise called the package, the package visibility, right? So we realized that in terms of semantics, when you're coming up with these diagrams, these different types of visibility scales are represented in a certain way. So for instance, the plus sign is for public, a minus sign is for protected, private, sorry, the tilde sign is, or tilde sign, why are you calling me? Sorry about that. The tilde sign is default, protected is a hash, and then there's certain weird things that we tend to find, right? Like derived attributes, for instance, are represented by a forward slash. A static attribute, if you remember, I don't know if you had a discussion of what a static attribute entails, right? You represent that with an underline, right? So when an attribute like type here is underlined, this signals the fact that it's static, right? And then the variable names is a no-brainer here. We know that it's nothing more than the name that you're going to give to this particular attribute, right? So if you have a class, like if you plan to have a class called, let's say, ICT 3020, for instance, right? We're saying that you'd have things like private string host name or some stuff like that. I don't know what the naming convention in Java is here, but I don't know. Class name was used kind of case in here. Class name is equal to ICT 3020, right? Fundamentals of software engineering, something, and project manager. I don't know, management or something, right? So what we're saying is that what we're saying here is that the variable would be this thing here, right? The class name. The type would be, in this case, the string, right? The default value. This is in cases where you've identified an attribute that you'd want to assign a default value, right? In this case, the default value would be this. Yeah, I mean, the default value could just as well have been a course code, and then under your methods, like if you have a method that says set, if it's set is does a set method set a get which one has a return value? Set as a void, right? So public void set course name or something, right? I guess you'd say in here it would be string course name or something, and then in here you just say I don't know if it's course. No, what do you say in Java? Using this keyword, like this dot course name is equal to course name or something like that, right? So this thing, what we're saying is that you have a default value, but you know that in the event that you realize, oh, but the course name is not supposed to be ICT 3020, it's supposed to have a description, then you evoke the set course name method, right, which will do the magic for you. Right, but as besides the point, what we're saying is we just need to familiarize ourselves with the key aspects associated with an attribute, right, in a class diagram. These key elements here: the visibility, the variable, right, the type of the variable. These are for operations. We're looking at attributes: the type of the variable and the default value. This is the syntax here. This syntax is very important, right? The sign that you're using to determine the visibility, this full colon, these are all important things. The specific data type you're talking about, right? So if it's Java, lowercase s means a completely different thing, right? Remember that. This is interesting. One of the reasons we discovered why we're doing this is tied to this concept we introduced a couple of sessions ago, this idea of model-driven design. Right, so in the event that you want to automatically generate code using this thing you're seeing here, it's quite easy. It becomes easy and trivial if you've done the correct thing here in terms of the syntax for the class. And this, by the way, is the reason why you want to make sure that you follow the rules, because the case tools you are going to use are going to assume that you have followed the rules. Otherwise, you won't be able to successfully generate the code. I mean, I'm sure if you were to use some case tool to automatically generate code and then there's an error, for instance, with the data type, it will tell you to say there's an error with this particular data type. This language does not have a data type with code string with a lowercase s, right? So this is what we did. And then the last component, right, which we said is represented in this rectangle we're calling the class. The top part is the class name. The middle segment is your attributes, right? And then the bottom segment represents the operations. These would be the methods in your class, right? So let's say you're developing an application, a system, and you've got into a stage where you've identified 10 classes that are going to be associated with the system that you're implementing. Each one of those 10 classes is supposed to be represented like so, right? With the corresponding attributes and the operations. Granted, we did also mention that for certain specific types of programming languages, a la Java, for instance, and we're going to latch on to Java here because we know, right? We know Java. We introduced Java in 2010. Interfaces, abstract classes are represented in a completely different way, right? Interfaces, we discovered you have double chaperones up there with the word interface in them, right? On top of the object name. This is how we represent them. And we discovered that we could do this using tools like Dia, right? or D, I don't know how they pronounce this, doesn't matter though. So if you use a class like dia, for instance, and you say this class we are calling, this thing we are calling ICT 3020 is in actual fact, ICT 3020, an interface, what we're saying is 3020, wow, 3020. It's an interface, oh, there's no interface here, but the abstract class, let's say a dia apparently doesn't have a way of representing, at least I haven't looked at this, of representing an interface. It's quite sad, really. But assuming if it's a normal class, it's going to be represented like so. If it's an abstract class, notice that it's in italics, right? So the syntax that you're using is extremely important. In the event that you wanted to specify that this was an interface, what we're saying is you need to, and if I can just latch on to this thing here, let's see chat. If I can just, I guess you remember this, right? You have your object name on top, the double chevrons like so, and then you have interface, right, on top. And then you have, let's say, ICT 3020 here. Right, we're saying this is how you would go about, I guess you do this anyway. This is how you'd go about representing your class, right? Not that hard. It's all about syntax, really. I think this is probably the simplest thing you ever do anyway, but that's just me thinking. I don't know what the thinking is for other people here. So this is what we're saying, right? This is how you would represent an interface. And of course, it's supposed to be somewhere at the bottom here. It's supposed to be like so, right? Anyway, so this is your interface, and then if it's an abstract class, this is in italic. If it's a normal class, you just leave it using a normal font face, right? No styling whatsoever, so just blank or the default option. All right, so so we're saying the third segment represents the operations or the methods, right? And we know these methods. The methods are contextual. They're actually dependent on what the class is meant to do, right? And what the class is meant to do is associated with the core functionality that you're implementing. But it's neither here nor there. What we're saying is that the way that you represent these operations is more or less similar to the attributes. You specify the visibility, the name given to the operation. Optionally, the parameters, not optionally, but optionally because sometimes a method will not have parameters, right? So the parameters, including the return types of the parameters, so including the data types of the parameters, and in certain instances, I guess the visibility of the visibility, but I guess the visibility of the parameters as well, and then the return type of the method, right? A method always has a return type, and the return type is either a specific type of data type or void, right? So void means nothing is going to be returned by that method, right? So it doesn't return any value. But the syntax is pretty much the same, right? So you have the visibility, which is dictated by either public, private, default, protected, or I guess these are not, we are ignoring derived and static here. So it's public, private, protected, or default, right? And we discussed what these do actually in 2010, which is quite nice, I guess. So the plus sign, the sign here will determine the visibility. The next thing you have is a specific method name. Now here, I mean, the name, obviously, there are certain conventions that you tend to follow, but if you want, the conventions that are specific to different types of programming languages, but if you want as a group, you can adopt your own convention. Doesn't matter, right? Convention is dictated by the programmers, the people writing code. It has nothing to do with the syntax, right? But it's always nice to lay down rules associated with a particular language. Why is that important? It ensures that your code is going to be future-proof. In the event that somebody else comes or joins the group, the programming team, and they're told that you're writing code using Java, they'll be able to figure things out if you're using some well-known convention, right? And so the method here, and then optionally you have the parameters, and we know the parameters, right? I mean, so if you look at this, what we're saying here is the visibility, the return type, the name of the method, right, or the operation, the parameter, right? The parameter data type, the parameter name. And you can have more than one parameter, right? We know how to do this, right? Comma separated things here. We can have string, wow. Oh, course code, right? Course code, right? In which case here, you'd probably have to have a private, I don't know what the codes are, or the strings, I suppose. Yeah, ICT 11, course code, right? And we did something stupid here. We shouldn't have, here's where you do the fundamentals of software engineering, project management or something. Some crap like that. But so is, oh, sorry, I forgot the semicolons here. So this is the thing here, right? You can have, so if we say set, okay, maybe we'll have, maybe we'll create a set course details. Let's say we have some strange thing like set course details, which latches onto these two private parameters, right? Or attributes called course code and course name. So you feed it like a course code, and it would be nice if we could follow the thing here. Right? Course code and maybe course name here. Well, what I'm trying to say here is that you can have 0 or more parameters that must have a data type. What type of parameter is it? The data type, the attribute, and the default value. You can have a default value in here if you want to. I guess default value is triple V or something. And default value here is K, not the KKK, but maybe LL, not LL, not DGG or something, right? You understand this? So, so it's simple, right? Simple syntax. And the beauty with this, right? If you do this right, you can actually find tools where you automatically generate this code. So you wouldn't have to do what Lightroom was doing here, where I'm manually writing these 10 lines of code. It would be automatically generated for you. And it wouldn't be 10 lines of code here, because these tools that you use to generate code using this sort of artifact, we will know that when you have a private attribute here, it's supposed to have corresponding set and getter method. So it will automatically generate your set methods for the course code, set method for the course name, get method for the course code, get method for the course name. And it does some wonderful things like it knows how to name this. So it will name this get course name. It's wonderful, actually. I wish I had Eclipse. Well, I don't know. I wish I had Eclipse installed and installed the appropriate plugin. I would have shown you exactly how. I would have shown you exactly how the code is generated, right? But we're not interested in that. That's not our concern. I do encourage you to look into Eclipse if you wish to automatically generate certain portions of your code, right? Sadly, I don't have any recommendations for PHP. If you're going to latch onto PHP, seeing as you're being introduced, or you have been introduced to PHP in 2010, right? I can't really, I've not really worked extensively with PHP myself, so sorry, I can't help there. But anyways, so again, in terms of visibility, you notice that the visibility itself is associated with both attributes and the operations, right? Usually, traditionally, you tend to associate the private modifier, right? So private to attributes, and then typically most of the methods will be public, right? Do you remember the concept introduced to you about information hiding, right? You discussed this in 2010. All right, and then I don't know if there are any questions with regards to operations here, right? And attributes. If there are no questions, then I guess we can just briefly talk about relationships associated with the different classes, right? We're not just modeling the attributes and the operations. We need to also specify how the different objects that are associated with the system we're implementing are related to each other, right? It turns out that there are certain types of relationships that you want to associate with your class diagram. Very important things here. And some of them are quite important when you're generating code, for instance, like things like generalization, right? So I don't know if you remember this, but when you have a parent class, a superclass, and a child class, right, or a subclass, the interesting things that happen, like for instance, for you to make use of the constructor in the parent class, use fancy things like the super keyword, right? And that thing, right, the things like the super keyword will automatically generated for you, default constructors associated with your classes will be automatically generated for you. This is how cool this is, right? Model-driven engineering. This is the thing here. It's the future, I think, in my opinion. But of course, I guess people will tell you that Agile is the future. Maybe, I don't know. So, so relationships include generalization, which I guess is the most widely used, or one of the most widely used here. And you're typically modeling sort of inheritance that might exist between classes, right? So if you have a parent class with different child classes, as is the case with this exemplar class called user, if you remember here, if we're going to double back to the class diagram, right? So that you, sorry, the use case diagram, so that you remember that, so if we had a user here, we're saying that we have a generalization sort of relationship that exists because the student, the student and the library staff, these are all users. If we had an administrator, it's also a user, right? So if we have a user, a generic user, and then we have specific roles that are associated with different types of users, the argument is that obviously those different types of users surely should have some certain things in common, right? Like maybe things like attributes like username and password. If those are common, why can we not model our use case diagram in such a way that we explicitly showcase or factor out things that are common amongst these different users? So in this case, obviously, we have a user, and then we have subclasses associated with the different roles, user roles, so library staff, student, and administrator, right? This could have been anything. I mean, if you're developing this pet project associated with a functionality that's going to be performed by a lecturer and a student, you could just decide to say, well, we're going to create a class called user, and then we'll have subclasses called student and lecturer, right? Student and lecturer will have probably certain things in common, but they might have other things that are different. Like a student will have a student number. Now, Lighton doesn't have a student number. I did have a student number, but it's disabled, I guess, I don't know. Different methods, right? There are certain methods that will be common amongst different users, but specific to the child classes or the subclasses, right? Parent, child, super subclass, right? Is this making sense here? I don't know. So you're typically modeling things like the inheritance between classes and implementation of interfaces, right? Remember interfaces and how different they are to abstract classes. Anyway, so in terms of the specific syntax associated with class diagrams, when you're modeling these things using Dia or Lucidchart, specifically if you're taking advantage of UML 2.0 or diagram.io, the way that you represent the generalization relationship is it's an arrow directed from the child to the parent. So if you look at these contextualized portions of the diagram, it's a hollowed out arrow, right? It's not filled, it's white. That's one way of looking at it. And the direction is from the child class to the parent, or from the superclass, from the subclass to the superclass. It turns out that the type of the arrow will spell out the type of the parent class. So if you have this sort of situation where you have a solid, if we had a solid line, black line, it would mean this is pointing towards a normal class. If it's a solid line with a white arrow like we have right now, we are pointing towards an abstract class. If this were a dashed line with a white arrow, this would be an interface, right? So different ways of, and this, again, this is important because you might want to automatically generate this code using a case tool. Even more importantly, you might not necessarily be involved with the gory details of the implementation. Maybe your role ends, you've just been employed as a business analyst, and what you do is you're producing maybe a software design or something. You're just producing design artifacts. So your job ends here. Because your job ends here, you want to make sure that whatever you're producing is going to be easily interpreted by the people who you might not know, who will be able to read the things you're producing. Which is why the rules are extremely important, down to the small little minute details like what we're talking about here, right? This thing here, very, very important. Okay, and then the other type of relationship that you probably come across here is association that would tend to model things like aggregation and composition, right? And usually it becomes really important when you're interested in trying to model a whole part relationship. If you look at aggregation and composition, they're more or less almost the same, but of course they're differentiated by the type of diamond that you use, right? One diamond is filled out, or it's black. The head is black. One of the diamond, the head, diamond's the head, actually. It's white, right? So aggregation is the less stricter type, which is represented by a white diamond, right, like so here. And you're modeling, or in both cases, you're modeling an is-part relationship, right? Aggregation is represented by, composition is represented by a black diamond. The only difference here is that this is a much more stricter variation of aggregation, because you are modeling a sort of relationship where the main class cannot do with a subclass, right? Or is it the subclass cannot do with the main? The main class cannot do with a subclass. It's like a fully functional human being who is alive must always have a heart, otherwise they won't be alive, right? So that would be modeled as a composition. Now, this is a very weird example, but light on maybe, no, I don't want, hair, right? Hair would be modeled, if you're looking at a human being, hair would be modeled as aggregation, because I could choose today to cut my hair, right? Go bald or something. I don't know why people do that, but go bald or something, right? That would be like aggregation, right? So it's a subtle difference, but it turns out it's important anyways. And then also the other type of relationship that you tend to model is the multiplicity, right? So if two objects are related to each other, you use multiplicities to explicitly state how exactly they are related to each other. And you do that by specifying some sort of verb here, and the multiplicities, right? How many of this object will be related to the other object, right? So in this case, what we are modeling is a many-to-many relationship, and what we're saying is that many users can deposit many digital objects, right? This is similar to what you're doing or what you've done when you're doing entity relationship modeling in 3010 really. The only difference is that, and I think I mentioned this in one of the sessions we had, the only difference is that is the naming really. In entity relationship diagrams, you tend to refer to these as the cardinalities, right? I don't know, is it cardinality or something? I don't know if it's right, multiplicity as well. But anyway, so many is represented by this asterisk. One is represented by a one, obviously, and so the name signals how the two objects are related to each other, right? So this could just as well have been, if this was a postgraduate student, we would say a postgraduate student, many postgraduate students would deposit one digital object, perhaps. Why? Because maybe two, right? Potentially one or two or something, I guess. Yeah, because at UNZA, the only thing a postgraduate student we have is a master's and PhD. So if you do a PhD and master's at UNZA, then technically speaking, you can potentially deposit two manuscripts into the IR, right? Right, so association. Yeah, I mean, so I don't know if there are any questions, but if we were to put all these different things together, right? So just to tie the different pieces together, what we're saying is that once you come up with your class diagram, right, structural model, we expect you to come up with something similar to what's on this slide here, right? And you have all these different elements associated with a class diagram, right? So you should be able to model different associations that exist. So things like generalization for modeling parent-child class relationships, aggregation and composition, right? For modeling an is part of a relationship or something. Things like the multiplicity to signal how two unrelated objects are related to each other, right? What sort of relationship association exists, right? And you want to be able to specify things like the multiplicity and the name of the relationship. I don't know if people have questions before we just briefly walk through how we get to do this with Lucy chart. Are you still there?
Yes, sir, we are here. We can hear you.
Oh, great. Good stuff. So, I mean, if there are no questions, then I just want us to I don't know, unless if there are any questions, I want us to gloss over how we get to do this in Lucy chart, right? So how do we get to model this in Lucy? Granted, you could pretty much do this in Dia. You can do this in Visual. If you're using Visual as a group, you can do this in, I Wow, I can't paste. You can do this in draw.io. You can do this in YEd. I mean, it doesn't matter what tool you use, right? Who cares? It's like, oh, can you write an assignment? Do you think the lecturer cares whether you're using Microsoft Word or I don't know, right? I wonder if we can model this ICT with education. Wow, I just thought about this. This would be nice. Okay. So anyway, so how do we do this using Lucidchart? Well, same process, right? Same, just the same as we were doing this with context diagrams, with use case diagrams. It turns out it's the same, right? If you are coming up with a state machine or an activity diagram, you'd go through the same process. Two main ways of doing this. Either you start on a blank slate, right? You create a blank document, or you take advantage of the many templates that already exist. And by the way, you yourselves can create a template and contribute to Lucidchart. This is how nice life is, right? But anyway, so if you decide to start off on a blank slate, same process, you go to Lucidchart, log in with your UNZA assigned email account. Do not be like I saw him, Jackson, right? Where you're logging in with your personal account. You won't have access to some of the paid for features in Lucidchart. You will not be able to share your artifacts with your colleagues. You cannot collaborate if you do not use your educational account. Told you this, right? So log in with your user assigned email account. If you're starting off on a blank slate, I mean, same process, you just click the plus shapes button, and then all you do is you choose, you scroll down on the pop-up menu that will come up. The left part of the pop-up menu will have the different types of diagrams that are there. You can either search for what you're looking for, or you can just scroll down. These are added in alphabetical order, right? The types of shapes. Scroll down to somewhere where there's a U, you have the UML diagrams, and then you can expand this and then choose UML class diagram, right? Once you choose this, you have access to this thing here, this shape component. If you do decide to use a template, all you do is, instead of coming up here to choose a blank diagram, you just choose template. And then once you choose template, you can go and search for class diagram, right? Top left corner here. Once you search for class diagram, you will have access to different types of templates that already exist. Take a peek. Unlike the context diagram, where you must explicitly choose the data flow level 0 diagram, because that is what we are focusing on. In this case, it doesn't matter. UML class diagram will always be UML class diagram. They're just the same. The only difference actually that you find in these different templates is maybe the color and the type of template. Some of them are banking applications. Like this is a class diagram for my ATM machine, right? This is a class diagram for an online shopping cart. So just take your pick. It doesn't matter which one you pick. It's going to modify everything anyway. This is an UML diagram for an API diagram. I wonder what that is. But anyway, so you search for class, and then you choose the template you want. You'll be presented with something like this. If you're happy with this template, you click on open template, and then you have access to your template. And then you modify your template. The goal is for you to come up with what you're seeing on this slide. And this is coming as part of assignment number 20, is it 24 or something? I don't know. As part of probably 24 something, the design. No, you are not expected to include the class diagram in your SRS document. No, right? I don't think it's there. It's not part of the SRS. I don't know if it's there, but if it's there, you include it. But it's going to come back in the design assignment, right? Right, so, I mean, I don't know if people have any specific questions, but just to try and put everything to perspective here, what we're saying is, if we were to walk through what we're doing in Lucidchart, is you go to Lucidchart and then, guys, I think this has changed. Oh, Lucidchart document. I thought it had changed. It looks different here, interface. Actually, they've changed this, right? Have you noticed that? Wow. Life is quick and swift, right? Last time it was an orange button with a plus sign, but now it's oh wow, okay, it's changed. Interesting. It's only been a week and it's changed already. Evolution, right? Remember what we discussed about software evolves, right? Evolution, like maintenance, bug fixes, feature enhancements. Lucidchart just evolved. All right, so it doesn't matter though, the idea is the same. You click on the new button, and then you choose whether you want to start a template or a new document. And I know I got an email about Lucid Park boards, right? It's a new feature. They sent me an email, which is quite nice. I'm sure they sent you an email as well. But anyway, so if it's a blank document, you click on your document here, and then what you have access to is a blank document. Once you have access to a blank document like light on screen right now, you go to plus shapes, this button here. Why? Because you don't have a shapes for UML class diagrams. It's not there. So you need to add it there. You click on that, you scroll down to these are added in, this is organized in alphabetical order. You scroll down to where you have UML. Expand this. Scroll down and choose the type of UML diagram you're interested in. Class diagram. Use shape. Once you do that, you start creating your classes, right? Class there. Oh, wow. You see, when you start with a blank thing, zoom in. This is interesting. When you start with the blank document, once you pick a class, this class entity here, it has all these placeholders, right? Have you noticed that they know that people like you might make mistakes, right? So they're telling you to say, this is how you're supposed to create your things here, right? So you could come here and you say, ooh, this is a course code or something. What happened? Course, okay. Course code, right? And course code, the type is string. And no attributes for a class are private, information hiding, right? Oh, what about course name? Okay, course name, that's fine. String, we'll have a default value. To just create software. Oh, we have a default value. We'll call this ICT 3010. I don't know, operation, same thing, right? So if you're starting off on a blank slate, you do this. If you have 10 classes, you do the same thing with 10 classes. Quite easy, really. And as you're modeling these relationships that exist, let's say it's a relationship between, course and student, and this we're modeling a relationship between, let's say, we're modeling a relationship with the BICT with education program, right? So we're saying many students in our department, in fact, students enrolled in the BICT with education course, many students can take many courses. Now, maybe we can refine this further and specify a number of courses, but it's many courses, right? And be very careful with the sort of relationships that exist here. What we're saying is that if you look at this, right? If you click on that arrow, I don't know if you can see what's happening here. If I click on that cog, can you see the cog? What's happening with the cog? Jesus, I'm sorry. Can you see what's happening with? I specify a relationship. I'll contextualize where I want the relationship to begin, student to course. When the orange, or I don't know if this is red or purple, whatever, appears, I will drag this. I'll click and drag, and then I connect it with that. Once I do that, the cog appears. Once you click on the cog, you have two options. Add multiplicities and reverse arrow direction. Add multiplicities will allow you to specify the type of relationship that exists between this and that, multiplicity, right? Also, is the thing here. You can change things like colors and whatnot, right? But anyway, so this is it. Very easy, right? And then we can say student. When you want to specify the name of the relationship, you just double tap and then the text thing will come up. You say student enrolls, I guess, enrolls into a course or something, right? Also, if you want, you can increase the font sizes here so that these are more legible, right? I guess 12 is fine, right? Or something. You can further stretch this out so that it's much more visually appealing or something. The usual stuff, right? Software is software. It's the same things here. We can also change these font sizes for these multiplicities. Take them to 12, I guess. I don't know. Oh, wow, it's not changing. I don't know. Maybe. Anyway, it doesn't matter. All right, so we do that, and then modeling. So modeling things like generalization and composition is the same thing, right? You drag this, and we're saying is the student class is going to be a parent class, but we know that we have a child class called ICT 30, or not ICT 3010, but maybe third year, yeah, third year student or something. We know that a third year student is meant to be like a third class of a generic student, right? And the way that we model this relationship as well is it's a directed arrow. All we are saying is that this is pointing towards, sorry, until it turns purple, you drag it and then you connect it. The way that you change the arrow type is you just contextualize the arrow and then you go up here, you change the arrow type. In this case, we are modeling what? Generalization. What type of generalization is this? I don't know if people remember the type of generalization here, but it's a, well, assuming the student class is a normal class, we use that. If, according to that syntax we're talking about, right? If, on the other hand, it's an abstract class would do this or something, right? So listen, I mean, this is, I don't know, this is not that hard to do, right? And then you'd come up, this is how you go about coming up with this thing here, right? So you have all the different components here. It's just a point and click and drag, really. If you have a mouse or you have a phone and you have a thumb, there's nothing to it. You just have to read and understand the syntax we are following through. Syntax associated to how you represent attributes, operations, the different types of entities, either it's the class, an interface, an abstract class, multiplicities, composition, aggregation, and generalization. I'll pause here. I was hoping that we would be able to start with sequence diagrams. That's fine. We'll finalize sequence diagrams tomorrow. Which when we do that tomorrow, then Sunday we can, it will be good actually. Sunday we can Saturday we'll tie the different pieces together, tell the story. Story related to these system models we've been discussing about. And then Sunday we start, I want us to start configuration management on Sunday. Are there any questions?
So, Doc.
Yes, sir.
Yes, I didn't understand clearly on the notion of interfaces.
The what?
Like,
I don't know. What were you told about? What were you told about what an interface is in 2010? I don't know.
I don't know. Maybe I missed class, but I don't remember having learned.
Well, I don't know. I mean, I'm assuming you learned this. You learned this. You're pretending.
No, Doc, I can't pretend.
Yeah. So the fundamental difference is that your interface is just it just specifies the signature of the method. So you don't have a default implementation. That's one of the major differences. When you come up with an interface, you come up with an interface with the hope that you're going to come up with a more concrete implementation of the interface. An abstract class, on the other hand, can have a default implementation for your methods. That's one of the major differences. But also, if you look at Java, the other difference is in the syntax, right? So I can't quite remember how an interface is created in Java, but I was hoping you would do that. You would tell us how you create an abstract class in Java, right? Yeah, so I mean, I'm assuming you know how to implement these things. I'm just explaining the, I'm explaining the design part of what you're doing, right? Because, and here's the thing, right? So another way of looking at what you did in 2010 is like, and this is what you should do maybe, because we won't cover this. Can you try and reverse engineer some code that you created last year, right, into a class that there are tools that you can use to convert code into like some design artifact or something. Anyway, so yeah, revise 2010, and I know that you have done this in revise 2010. I know that you have done this in 2010. Go and reread what you've done in 2010. Yes. In PHP, it's the same idea. It's PHP is an object-oriented programming language, right? So I'm being introduced to the same thing. It's just that
we haven't started PHP. We are about to conclude with CS.
Oh, okay. I see. Right, that's fine. I mean, But the fundamental difference really, that's okay. The fundamental difference really between, I guess, the interface here is what it does, right? And then also how you get to define it, right? So a normal class, I guess, would be like public class, similar to this or something. So you'd have, this is your normal class. If this was an abstract class, you'd have public abstract class, ICT 3020 or something. If it were an interface, you'd not have the implementation here. So a public interface ICT 3020 or something. Right? This is what you did, right? You did this. If you didn't, I mean, just revise. This is trivial stuff. I mean, it's just like a reminder of what you covered in 2010 or an extension of what you didn't cover if truly you didn't cover this. But it's fine. This is what we are planning for. Here's the thing. I'm about to release an assignment. I thought we'd be done with the sequence diagrams, but I'm releasing an assignment. This assignment is, really? This assignment is, you'll find it on the Moodle. I'll send out an email to that effect here. I'm concerned that it's like people have not really started the requirements in extension. To force you to do this, the deadline for you to finish conducting the extension process, collecting the data you need is next Friday. And then the deadline for the complete version of the SRS document is Friday after next, which is the 23rd. We need to start writing code now. We've set the stage for the basis for us to start writing the software. So we should start writing the software, which is why beginning day after tomorrow, we start discussing how you collaborate with other people when you're writing software, configuration management, right? So if there are no further questions, then until we meet again, which is tomorrow, I believe it. Why did I not? I do apologize for this. I thought, wow, I didn't schedule. So we have a meeting tomorrow. Oh, it's there, right? It's 16. No, it's not. Okay. We have this. Sorry, we have this. Whoa. We have a session tomorrow at 16, right? Just duplicate this, and then I'll set it up. Tomorrow is the 10th. We have the meeting tomorrow at 16. Sorry about, yes, save this. And we have a class. I'm not invited, okay. And then we also have a class on Sunday. We're making up for lost time. Is the 11th, 16th, 17 as well. I do hope maybe we can finish configuration management by Monday. That would be nice. Or by that other week, so that we can already start. If we finish configuration management in this week, we can probably start testing here, and then maybe try and see if we can do the experimental computer science part here, right? Experimental software engineering, sorry. Okay, see you when you see me, which is tomorrow at 16 hours. Thank you very much. Good day.